Okay, it's Matd1534, and today we're going to start Unit 9. So we've done Unit 8 now, and Unit 8 is more about the straight line, the parabola, and then the piecewise functions. So 9 will be now about the absolute value graph, and then also incorporating it into our piecewise functions. So we can now, for instance, have a piecewise function with a combination of a straight line from here to there, a parabola from here to there, and an absolute value maybe from here to there. So let us just see. Okay, so when we look at our absolute values, we must remember that we have done the absolute values, and we said, just to refresh your minds a little bit, when we did it, we said it's like a distance or a length or even a radius, but the point is it is always positive. Um, so whatever is inside here between the vertical arms will be giving a positive answer. Okay, so if I have the absolute value of -5, that will be 5. And when I have the absolute value of 5, of course, it will also be 5. Because the distance from 0 to 5 will be 5. And the distance from 0 to -5 will also be 5. Okay, so we mustn't confuse the points, which is 5 and -5, with the distance, which is +5. Okay, so that side there should be positive, but the right-hand side we said. But inside the two arms, we can have a negative, but the answer of that negative will be a positive again. Okay, so when we now start doing the absolute value graphs, it is very, very similar to the parabola. It's really very, very, very similar. And if you understand the parabola, you will surely understand the absolute value graph. So the standard form here, we're going to use y is a. I may use other symbols, but just to help you now, as I say, this is our introductory lesson. So plus q, where you had for the parabola a x minus b squared plus q, you see. It's just the same. So this PQ will be again, but now we can't say turning point because this is not a turning point here. We say a vertex. The Americans use vertex, or we call it a salient point. A salient point. That's an I there, T, salient point. Okay, so just please not a turning point. And please, these are now straight lines. The two arms are straight lines, okay? So it's a salient point or a vertex. Okay, and then, so if we want to find the salient point, just like the parabola, we said the turning point here is going to be PQ in the parabola. Now it's exactly the same here. Our salient point or our vertex is going to be PQ here. And then we're going to work out again the x-intercepts and the y-intercepts. So really, it is so similar to the parabola. The same story. If my if my A is positive, my arms are up. And if my A is negative there, the absolute value graph will be upside down, just like the parabola. Okay, so as I say, if you really understand the parabola, this absolute value graph is not difficult. And then if you did do your notes nicely when we did absolute values, sorry for that. I just want to close that. If you made good notes when we did the parabolas, I mean the absolute values as a topic, then this is going to really be easy for you. Okay, I just want to quickly write again that formula there, and then just look now at this example. So y is a absolute value x minus p plus q. Okay, so now remember now we call it the salient point or the vertex. So, okay, if we then have this example, then surely that is a 0 there. Okay, therefore, our salient point is actually going to be -1/2 and 0. And that's what you see down here, -1/2 and 0. Okay, now when we did the absolute values, we said that forms like a curly bracket. Now you can understand why did we do the piecewise functions. Because this is a piecewise function. You see, there's the one piece and there's the other piece. That piece there is to the right of -1/2, and that piece here is to the left of -1/2. So this is actually 2x plus 1. You see, the book builds on top of pre-knowledge. So we did now the piecewise so that you can understand this. Okay, and then we have the negative arm, the positive arm and the negative arm, because remember that there can now be positive and negative. We said we can have a 5 to give us 5, and we can have a -5 to give us 5. So basically the inside can be positive and the inside can be negative, and this is exactly what happens now. And then that will be our piecewise function. Okay, so uh, in other words, the right arm, the positive arm, will be greater than -1/2. It's always at the vertex. That change here, the change here is, and here of course, is always at the vertex. Okay, so you don't really need to be a chopper pilot to get that. All right. The other question that I often get, and it was interesting, so many of you asked a similar question for your work, and I appreciate those questions. People, listen, just use Classroom. Please don't use WhatsApp because I cannot follow you there. It's impossible for me. You can rather send your message for me in Discord, because Discord is open on my, as I told you before, it's open here the whole time because I'm teaching basically the whole day. And I will see your message and I will respond to it when I get a moment or a chance. You can even load your photo into Discord for me if you really have a problem, and I will quickly respond to that the moment I get a chance. But don't use WhatsApp, please, or either in Classroom itself, because then I do get the notification and I can go back. WhatsApps, I really look at the evenings and sometimes early mornings at them. I don't really follow the WhatsApps. I just don't have time to follow the WhatsApps because, as I said, I'm busy teaching the whole time. Now, what a question was is, where must I decide where this equal is going to be? Because remember, this point is included there now. So where must I now put this equal to? That is your choice now, you see. So I've decided I'm going to put it in the top one. And then, but don't put it in both, okay? Because we must make a choice where we're going to put the inclusion. We don't put them everywhere. So also when you do that assessment assignment, that informal assignment or something, I can't remember the name now, don't put the equal for all of them. Decide where you want to have them. You can decide. But listen now, for absolute values specifically, we put it in the top. It is just a gentleman's agreement. We put the equal in the top. So there's no hole there. So if I have a peas and a pears, I must have an inclusion somewhere. And we decide to put it at the top. Okay, so basically this is then what your graph will look like. Now, there's a couple of things we must just, as I say, this is like an introduction. So we must understand that, I hope I will get this right. Let me just see. Sometimes this gives a bit of a problem, but let me go there. Yeah, at -1/2 now. There we have our axis of symmetry now. Okay, so that means that if I have a point here, and I go over that axis of symmetry, I will get the same y coordinate there. So if I, for instance, make it -3 here, -3, then it's 5. It's minus 3, 5. Okay, and then that distance now from minus 3 to minus a half is 2.5. I mean, I'm at minus 3 and this is at minus a half. So the distance from the minus 3 to the minus a half, that distance there is 2.5. So if I go 2.5 over on the other side, I will land here at 2. You see, you can see it there, 2. And that will also give me then 5. So remember, we have to put 2 points on. So that's a nice point to use. Use the same point this side and that side. Then it shows your symmetry. Okay, so basically, remember this was now x is minus a half, the vertical asymptote for the absolute value graph. It's really not difficult work. I hope you understand. So, yeah, I have given you now a table. That is for people just to see that it works. But remember, we're not going to use tables anymore. We do the salient point, x-intercepts, y-intercept. If it was in normal situation, in a class situation, I would have said, do this quickly for me in class. But because of the lockdown and the time, and so I want to rather get to, you're not going to get this in a test or in an exam, that you must complete a table and all that. This is for understanding, and you can still do that for yourselves because you have the book. But what I'm going to do is I'm just going to do this with you now here again. So we're going to use this little graph that you are used to now, and then I can take you through them quickly. So we saw now that, yeah, so if the mother graph is the absolute, that we said even early in Unit 8. So the mother graph is our absolute value of x. Okay. And clearly there you can see the V shape now. And this is going to be 40. I'm just going to zoom in a little bit. Go back. Go here. Zoom in a little bit. Okay, but I think you can see it nicely. So it's the 45 degrees. So 5, 5, 10, 10, minus 5, 5, minus 10, 10, so etc., etc. Okay, if we go zoom in like that a little bit. Maybe that will be even more clear for you like that. Okay, so that's the mother graph, the absolute value of x. So what this is trying to do here now is the same as what we did with the parabola. What happens if we change the values in front of the absolute value and that q value? So if we can go to this one, absolute x minus 2, and I just put it in here as the second function. So we do absolute value x, and then we have the q to be minus 2. I know you're going to know exactly what is going to happen now. If you understand, you should. And then you can see, yes, exactly, it moved 2 units down. And because it moved down, I can work out x-intercepts here by putting the whole thing equal to 0. And those solving absolute value things we have done already. So there's the absolute value x minus 2. If we can quickly just put in absolute value, absolute x, and we do the plus 2, let's take, isn't it Mother's Day Sunday or something? So let us use a pink. Okay. All right, and there we can see the whole graph moved up 2 units. And because it's positive, its arms up, it's not going to even touch the x-axis. So I'm going to be not logical if I try to work out now x-intercepts here. This is not going to be logical at all. So I need to keep my logic in mind. Okay, and then we have here like 2 times the absolute value of x. So let us just, I'm going to just raise those 2 and then just put together with our mother function the 2 times the absolute value of x. And I'm also sure you're going to know what is going to happen there. 2 absolute value of x, and let us just, okay, I can keep the pink there now. Okay, and there you can clearly see that stretch factor again. It's really stretching it out now. It's coming closer to the y-axis. So it does exactly the same things that you will expect in the parabola. Let me just do like a quarter. And there you can see that it is really flat, almost at the ground level now, because of the shrinking factor now. Remember what we said, that bigger than 1, stretch it, and less than 1, like a fraction, shrinks it. So it bends it down. It's like you take the two arms and you press them down towards the ground. Okay, so there is everything happening exactly the same as we were used to. Okay, so let us just also do this now. So if we start putting negatives in front now, then you already know now. So I'm going to keep the mother graph, the absolute value of x graph here, and I'm just going to put in then for us negative absolute value of x. Okay, and then surely you will know it's going to be arms down now. Okay, and then the last thing now that we just basic stuff now. What happens now if we do like x plus 1 and x minus 1? Okay, so let's take the x plus 1. So we do the absolute value of x plus 1. And then we see exactly as we expected, the whole graph moved 1 to the left because the salient point must now be minus 1, 0. The P, PQ minus 1, 0. I mean, if I look here, then this should be a 0 there. Okay, that should be a 0 there. And then the salient point will be minus 1, 0. And the salient point here should be 1, 0. And this is a positive, and this is a positive. So from there, arms up. So if we can just then, just for the good of it, just do that x minus 1, 1 also. Right, let's just take another color for it that we can compare. And I think there we can really see it moved 1 to the right. The salient point is 1, 0, just as we thought. So this axis of symmetry is going to be 1, and it's going to be symmetrical over that 1. So if I have 0, 1 here, I will have 2, 1 there, because the distance there is 1. So another 1, I must be at the same height. So if that is 1, then that is going to be 1 there at 2. Symmetrical over the 1. This one is symmetrical over the minus 1. So if I have a 1 there, and the distance here is 1, I can go another 1. So I'll be at minus 2, and then it should be at 1 also, at minus 2, because the graphs are symmetrical. Okay, so this concludes actually now the basics on the absolute value graph for this morning.